Welcome to my algebra class. We're on chapter 10, section 5 on absolute value. Absolute value turns into compound sentences because in absolute value we can have two possible answers, one positive, one negative. So if we have the absolute value with an equal sign, it's going to be a compound sentence connected by or, because we could have one positive, one negative answer. And I always try, I have a little kind of like a dance or a something to help memorize what happens. If you have the equal sign, you end up with the two dots on your number line, like two horns of a bull. So that's why I put the bull up there. So if I'm going to do number 1, x will equal 4, or x could equal negative 4. So when I graph it, I get negative 4 and a dot here and a dot here, the two horns of the bull. This one, the second one here is an or statement. It's x minus 2 could equal 7, or x minus 2 could equal negative 7, because when you take the absolute value of negative 7, that would work, make 7. So solving this, we're trying to figure out what x would be. We'd add 2 and we get x equals 9. If I put 9 in there, 9 minus 2 gives me 7. That would work. Or, make sure you keep the correct symbol there. Add 2 here, and we get x equals negative 5. If I put negative 5 into the original problem, I get negative 5 and a negative 2 make negative 7. And the absolute value of negative 7 makes 7. So that also works. And I should get the bull's horns. Here's negative 5, here's 9, and there's my solution. Now the next type would be absolute value less than something, and that's a compound sentence, that's an and sentence, and I call these the Russian elbows. Because when you graph, you're going to have numbers between, you're going to have between problems. So if you think of your arms as the solid line, your elbows as the dots, get to include your elbow or you don't. And if you would like to dance, go ahead. So this first one says x is between, remember it's x is less than 6, and x is greater than negative 6. That's the between problem. So if I graph that, here come my Russian elbows. Negative 6 and 6 are my elbows. And I don't get to include my elbows since there are no bars, and it's shaded in between. Those are my folded arms. That's the between. The second example, I put x plus 5 between 8 and negative 8. The absolute value can fall between 8 and negative 8. So solving for x in the middle, I have to subtract 5. And I get negative 13 is less than x is less than 3. Graphing it, I have an open circle at negative 13, open circle at 3, and here's my Russian elbows. You don't get to include them this time. Shaded in between. Now you can double check to see that this works. If I pick out a number between negative 6 and 6, such as 1, the absolute value of 1 is less than 6, so is negative 1. If I come over here and pick out a number here, let's say 2. 2 plus 7, the absolute value of 7 is 7, that's less than 8. I pick out negative 12, negative 12 plus 5 is negative 7, and that's less than 8, so it's correct. So we have equal is the two dots, the bull's horns. Less than, absolute value less than is the Russian elbows, shaded in between, an and statement. And then finally we have the greater than compound sentence, which I call the Egyptian, because you're going to have arrows going out, to one to the right and one to the left. So this problem becomes x is greater than 5, or x is less than, now remember it's going to go to the left, negative 5. I can have a negative 5 in there. So shading it correctly, graphing it correctly, I have -5 and 5. Open circle at 5 shaded to the left. Open circle at 5 shaded to the right. And there's my Egyptian. If you take your arms and just go out like an Egyptian, well, actually opposite directions, there you are. And you can pick a number here. For example, -6, the absolute value of -6 is greater than 5. Pick a number here, 7. The absolute value of 7 is greater than -5. And it has to be or, because there's no connection here. It has to be the union of those two. All right, the second one, the absolute value of 3x is greater than 6. That would be 3x could be greater than 6. Or I could have a negative value in here, or 3x is less than -6. And then divide by 3 to solve for x, so x is greater than 2, or divide by 3, x is less than -2. And then graphing it, we have -2 and 2, and less than -2 is an open circle shaded to the left. There's begins by Egyptian. And x is greater than 2, open circle shaded to the right. So when you have absolute value problems, you have 3 possibilities. If it's equal, you'll have the 2 dots. If it's less than, you'll have the Russian elbows. It'll be a between problem. And if you have greater than, you have the Egyptian. You have 2 arrows going opposite directions, like your arms when you do the Egyptian dance. We're ready to do the assignment, so you need a sheet of paper headed. Skip a line that titles 485, written 13 through 36. And we're on problem number 14. It says solve each open sentence and graph its solution set. So we have the absolute value of k plus 7 equals 3. Equals is going to be the bull's horns, the 2 dots. So write your compound sentence, k plus 7 could equal 3, or k plus 7 could equal -3. You have to write the compound sentences down, and be sure you put the right word in. So we subtract 7 to solve for k, and we get k is equal to -4. So if I put -4 in there, that would work. That would give me a 3. Or bring that down, subtract 7, and we get k equals -10, which would work. -10 plus 7 is -3. The absolute value of -3 is 3. Graphing it, we have -10 and -4. Make sure you place them correctly. A dot in both. There's the bull's horns. And this is actually what's going to be checked. Number 16, we have the absolute value of 7 minus y equals 4. Another 2 dots are bull horns. So we can have 7 minus y equal 4, or we can have 7 minus y come out to be -4. Make sure you put the or in. Let's solve for y here. Subtract 7 from both sides. We get -y equals -3. Multiply by -1, y equals +3. Or, solving for y here, subtract 7. We get -y equals -11. Multiply by -1, y equals 11. Graphing that, we put down 3 and 11 and dots at both. If I put 3 in there, I get 7 minus 3, which is 4. That works. If I put 11 in, 7 minus 11 is -4, and the absolute value of that equals 4. So here's my solution. Problem number 18, we have the absolute value of s is greater than or equal to 1.5. Greater than is going to be the Egyptians. So that's going to be s is greater than or equal to 1.5, or s is less than or equal to, it can be -1.5. And graphing it, we don't have any work to do since it was already solved for s. we put negative 1.5 down and 1.5. This says S is less than or equal to negative 1.5, so that's a closed circle shaded to the left. There begins our Egyptian arms. Greater than or equal to 1.5 is closed, shaded to the right. If I pick a number over here like 2, 2 is greater than, the absolute value of 2 is greater than or equal to 1.5, as is negative 2 on this side. Problem number 20, we have the absolute value of t plus 4 is less than 10. Less than is the between problem, and that's the Russian elbows. And I'm going to write it the short way. T plus 4 is between 10 and negative 10. So I'm going to solve for t. I'm going to subtract 4 from all three parts. I get negative 14 is less than t is less than 6. And I'm ready to graph it. So negative 14 and 6, they're both less than, so I have to use open circles shaded in between. And you can check it out if I pick, for example, negative 2 plus 4 is 2. The absolute value of 2 is less than 10. If I pick 5, 5 plus 4 is less than 10, so that's the correct area. 22, I have the absolute value of 4 minus v is greater than or equal to 5. Greater than is the Egyptian, so we're going to have two arrows going out. So I have 4 minus v could be greater than or equal to 5, or 4 minus v could be less than or equal to negative 5. Solving the first inequality for v, subtract 4 from both sides. You get the opposite of v is greater than or equal to 1. Multiply by negative 1. Now remember, multiplying or dividing by a negative sign turns the inequality. So we're going to get v is less than or equal to negative 1. Bring down the or. Here, subtract 4 from both sides, and we get negative v is less than or equal to negative 9. We have to make this positive, so we're going to multiply by negative 1, so v, turn the inequality, is greater than or equal to positive 9. Graphing this, we get our Egyptian dance. So negative 1 and 9, v is less than or equal to negative 1, solid circle shaded to the left, solid arrow. Greater than or equal to 9, solid dot at 9 shaded to the right, solid arrow. And I can check this out. Let's pick negative 2. Negative 2, 4 minus the negative 2 is 4 plus 2, which is 6. That comes out greater than or equal to 5. And over here, if I pick 10, 4 minus 10 is negative 6. The absolute value of negative 6 is greater than or equal to 5. So that's correct. And we have our Egyptian. Number 24, we have the absolute value of negative 1 minus b is less than or equal to 6. That's a between problem, so we're going to put negative 1 minus b between 6 and negative 6, using less than or equal to. Solving for b, we add 1 to all three parts, and we get negative 5 is less than or equal to negative b is less than or equal to 7. To get this to be positive, I have to multiply by negative 1, which turns the inequality, so this is going to be 5 is greater than or equal to b greater than or equal to negative 7. Looking at this, I can see the 5 and the 7 are in the wrong places for graphing, so I'm going to move it here, move them in the right place, and change my inequalities. So it's all the numbers between or including negative 7 and 5. Graphing that, closed circle at negative 7, since I have less than or equal to, closed circle at 5, shaded in between. And again, I can check to see if I'm correct. I could pick 1. Negative 1 minus 1 is negative 2. The absolute value of negative 2 is 2. That's less than or equal to 6. So this is your Russian elbows. Number 26, I have 4 times the absolute value of p minus 1 is less than 15. Now this is section B. it poses a little harder situation. And what I see here is the absolute value is not by itself, and in order to get the correct compound sentence, I have to get rid of anything outside the absolute value before I can break it into its compound sentence. So I'm going to have to add 1 first. So now I have 4 times the absolute value of p is less than 16. Then I divide by 4. If I don't do this and there's a negative somewhere outside and it turns inequality, I'll have it wrong. So make sure that you get the absolute value by itself, which I now have, and then I can figure out the correct graph. It's less than, therefore it's going to be the Russian elbows, so p is between 4 and -4. And that's ready to graph. So I put -4 and 4 down, open circles since they're less than symbols, shaded in between. Problem number 28. I have the absolute value of 2 minus q minus 3 is less than 1. So I'm going to get rid of that minus 3 so I can figure out the inequality, the compound sentence. So I'm going to add 3. So I get the absolute value of 2 minus q is less than 4. Again, that's a between problem. 2 minus q is less than 4, but greater than -4. So solving for q, we need to subtract the 2 first from everything. So I get -6 is less than -q is less than 2. Multiply by -1 to get rid of the negative sign, so that gives me 6, turns the inequality is greater than q, greater than -2. I can see the numbers are not in the correct order, so I need to turn that around, put them in the correct place, use the less than symbols, and now it's ready to graph. So it's everything between -2 and 6, but not including those. And problem number, so that was number 28. Number 30. We have 4 minus 3 times the absolute value of y is less than 1. So we're going to solve for y. We need to first get rid of everything outside the absolute value symbols. So that gives me -3 times the absolute value of y is less than -3. I divide by -3 to get rid of the -3, and this is why this is important, to get rid of what's on the outside of the absolute value, because the symbol here is going to turn. It's going to be the absolute value of y, whereas you thought it might be a between problem, it's actually an Egyptian problem, is greater than 1. So y is greater than 1, or y is less than -1. And graphing that, we put an open circle at 1 shaded to the left, an open circle at 1 shaded to the right. And you can check to see that those work. If I pick out -2, the absolute value of -2 is 2. So 4 minus 3 times 2, which would be 6. 4 minus 6 is -2, that works. If I pick out 3 over here, that would be 4 minus 9, and that gives me -5. That's great, less than 1, so it works. And we're going to stop at 30. So you can go back and change the assignment and remind me. It's going to be 13 through 30. And that concludes the evens, so make sure you check the odds in the back of the book for the answers. Get help.